It's been a little over 4 years since my review of the X1 Carbon, Bambu Lab's debut printer, and a machine that completely blew me away. Since then, they've been busy with the release of their P series, followed by the A series and their more recent H series line of machines, but we haven't seen a Gen 2 or a refresh of the original X series. Until now. Earlier this year, Bambu Lab told me they were finally bringing back the X series with the new X2D, and asked if I was interested in testing one out. While I've enjoyed my time using the larger H2D and H2C that sit on a workbench right next to my desk, I was excited to see a return to the X series and agreed to take a look. I've had this printer for a few months now and have thrown a variety of different test prints at it to see what it's capable of. In this video, we'll dive into the X2D. We'll go over its specs, what the setup process was like, how it's performed, and I'll share my overall thoughts based on my time with it so far. So with all that being said, and without further ado, let's get right into today's video. Let's start off by running through the specs. The X2D is a fully enclosed Core XY 3D printer, with a build volume of 256mm in X, Y, and Z, just like the original X1 Carbon. However, one massive difference between these two machines is that the X2D, which I'm sort of been calling the X2 Dual, has two hotends. When using the secondary hotend or both hotends in the same print, the build volume in the x-axis shrinks a little bit and you end up with a work area of 235.5 by 265 by 265 millimeters. As far as the build, the internal frame is made up of steel, and this is wrapped in some large plastic panels. They also use a bunch of injection molded pieces for all of the connecting joints. It has a glass front door as well as a top glass removable lid. For motion, X, Y, and Z all ride back and forth on linear rods and bearings. This is a departure from the carbon rods that I gave the X1 Carbon its name that were used on the X-axis. The bed rides up and down on 3 lead screws and uses the same single motor with a large belt wrapped around those lead screws to drive the bed up and down. Turning to the toolhead, this is where there are some big changes. The front cover looks completely different, and they have a larger layer cooling fan as well as a small backlit logo. It's held in place with magnets, so grabbing it and pulling it forward lets us see underneath. Inside, we have two different hotends. The one on the left is the primary hotend, and the one on the right is the auxiliary hotend. These both use Bambu Lab's newer style of hotend that keeps the electronics like the thermistors and heating elements in the toolhead itself, which makes for really quick swapping since the hotends are just held in place by a small metal clasp. Today's video is sponsored by VOXEL. Their VOXEL PLA Plus high-speed and VOXEL PETG Plus high-speed filaments are designed to be reliable, tough, and capable of high-speed printing without sacrificing consistency. At just $16.99 a spool, the pricing is super competitive, and they also offer bulk discounts along with free US shipping on orders over $75. VOXEL filaments are ideal for any print farm looking to use US-made filaments at a competitive price. Reach out to VOXEL for bulk discounts. Everything they make is developed, produced, and supported in the USA, and it's all tested in their 250 machine print farm. VOXEL also offers a full lineup of upgrades for Bambu Lab printers, including filtration and anti-vibration solutions, designed to improve print quality, safety, and overall reliability. Check out the link in the description to find out more about everything they have to offer, and for a limited time, use code MODBOT to save 10% on all orders over $100. Some of the differences between the two hotends is that the primary one sits in the toolhead stationary, while the auxiliary one pops down when it's being used and then moves up and out of the way when it's not actively printing. Really, the bigger difference between the two is that the primary hotend uses a direct drive extrusion system, while the auxiliary hotend uses a Bowden tube extruder, Bowden extruder, that's mounted on the backside of the machine. This is the biggest thing about the X2D that caught me off guard, and I definitely have some mixed feelings about it that we'll cover a little bit later in the video. Both hotends ship with a 0.4mm hardened steel nozzle, and the max temperatures is 300 Celsius. Both hotends have a small heatsink cooling fan, their own filament cutters, and there's a toolhead camera used for calibration mounted on the bottom right side of the toolhead. The printer uses automatic bed leveling, and while I didn't see anything obvious, I believe it's using a similar load cell setup to their other machines. For the bed, it's using a magnetic flex plate system, and it ships with a sheet of dual-sided powder-coated PEI. The max temp for the bed is 120 Celsius. As far as part cooling goes, this is the first time I have ever seen a printer outside of a custom build that ships with not one, but two auxiliary part cooling fans. The interesting thing about these fans is that they're able to draw in air from the outside using a mesh opening that's located at the bottom sides of the printer where the built-in handles are. The left auxiliary fan also has a built-in chamber heater that can be used to get the print chamber up to 65 Celsius. Depending on the material being printed, these fans have two different modes that make it serve very different purposes. For materials that just need as much cooling as possible, they will draw in the air from the outside. But for higher temp materials, the left fan works to cycle warm air from the chamber heater around the chamber, and the right fan helps to push air through the chamber filter. Towards the back right side of the machine is a built-in internal chamber filter, and this is about twice the size of the one that shipped in the X1 Carbon or the P series machines. For monitoring prints, there's a 1080p camera inside the front left of the printer with a swiveling cover, and LEDs in the front and left side of the machine which help to illuminate the work area. Moving towards the top back left, we have our poop chute for purged material, as well as two different levers. One of them moves two metal arms to pull purged filament away from the nozzles and down the poop chute, and the other one lifts up a soft nozzle scrubbing brush. Towards the right side, there is an additional nozzle brush, as well as a little metal arm that's used to hit a lever at the bottom of the toolhead, and that's what's used to raise or lower the auxiliary hot end. Interfacing with the machine is done using the 5-inch touchscreen located on the front. This is very similar to the one that shipped on the X1 Carbon, but it's using a different UI and is a bit more responsive. One thing that I am a big fan of that the X2D has over the X1 Carbon is a full-size USB port that's located on top of the printer above the screen. So if you are someone that is wanting to print locally and not even on your local network, you don't have to fiddle around with a micro SD card. Both sides of the printer have acrylic windows to let you see inside the machine, and located at the very bottom are built-in handles. Turning towards the back of the printer, there is a lot going on here. For now, I'm going to ignore the add-on accessories that I've installed. We'll touch on those later, and we'll just cover what's included with the base or core printer. Starting at the bottom, we have our power input and on-off rocker switch. And above that, we have our exhaust fan, which also includes an additional cartridge of filter media. Next to that is the output of the poop chute, and right above that, we have our buffers or our hub for both the left and right extruders. Moving up from there, we have 4 screws that can be used to adjust the tension on the Core XY motion system, and we have our Bowden auxiliary extruder. Unlike the direct drive extruder in the toolhead that's using a servo, the auxiliary extruder is using a more conventional stepper motor. The X2D came packaged nicely, and setup was pretty similar to any of Bambu Lab's other Core XY printers. This largely involved removing tape and plastic covers, and pulling out the foam and accessory box from inside of the machine. The version I got is the X2D combo, so I needed to remove a few bolts holding the AMS2 Pro in place before I could pull that out, and then it was just removing screws from the bracket for the AMS2 Pro, as well as the screws holding the build plate to the base of the printer for shipping. The lead screws came with little covers that had to be pulled off, and then it was just cutting a couple of zip ties from the toolhead, plugging in the ribbon cable on the LCD screen, and slotting that into place on the machine. Really, the main difference with the X2D setup takes place at the back of the machine. For the auxiliary extruder, you have to plug it in and slot it in place before grabbing the Bowden tube coming out of it and using a small wrench to attach a threaded coupler to it. Finally, the AMS gets plugged into the buffer as well as the external spool holder. Bowden tubes get routed and you plug in and connect the exhaust fan. I would say the unboxing and setup process is going to take about 30 minutes. Once powered on, the screen guides you through the setup process. This has you pick your language, optionally connect it to your local network, as well as the Bambu Handy app, warns you to make sure you've removed all of the packaging material, and then it runs through its initial calibration list. This was a fairly long process and took approximately 30 minutes. By far, the longest portion of the entire calibration is the motor noise cancellation, which has the motors run through a series of different accelerations and speeds and uses that information to tune those motors, making the overall motion much quieter. And the good thing is that you should only have to do that one time, and that's on the initial setup. After this completes, the printer runs through input shaping, a full bed mesh calibration, and then it does a nozzle offset for the 2 different hot ends. Coming from a time where you had to manually offset different nozzles, I always find this process pretty interesting. And on the X2D, it uses a series of sensors located on the back of the build plate to calculate all of your X, Y, and Z offsets automatically for your primary and auxiliary hot ends. That is the final step of the initial calibration. However, if you are using an AMS, the first time you do so, it needs to run a quick calibration. The good news is this only takes about 30 seconds. You load a spool of filament, click the button, it feeds it down to the toolhead to make sure that all the sensors are reading properly, and you are ready to rock and roll. I started off with loading a spool of VOXEL PLA and printed out the included benchy test print, which turned out great. As soon as that was done, I loaded a second spool of filament into the auxiliary extruder and printed out the 2-color flexible panda model that was also pre-sliced on the machine. Sort of as expected, having a dual color print with 1 color loaded into each hot end meant that the filament swaps were really quick, and there was no extra purge material outside of the small prime tower. From here, I was ready to slice up my own files. Since the X2D wasn't publicly available when I began testing, I used a private beta version of Bambu Studio, but as soon as it launched, I updated to the public version, which as of now is 2.6.1.55, and that's what I used for the remainder and majority of my testing. From here, I threw a handful of prints at the X2D, ranging from single color to multicolor using the auxiliary extruder, and other prints using the AMS2 Pro. Whenever I'm testing out a machine or some hardware, I do my absolute best to avoid watching any videos or reading anything about it. That way I can come to my own conclusion based on my own personal experience. However, in the case of the X2D, when this launched and people found out that it had a Bowden extruder, there was so much chatter about it that it was nearly impossible to avoid all of it. One thing I kept seeing discussed was the quality difference between the primary extruder and the auxiliary extruder. Based on Bambu Lab's product page and especially the marketing surrounding it, they are clearly aiming that auxiliary extruder as largely being a support extruder. And if you look at the compatible materials for the 2 different hot ends or extruders, I'm using those sort of interchangeably, the auxiliary extruder has a lot of support material listed. However, they also have a lot of materials listed that are standard filaments that most of us print with, like PLA, PETG, and ABS. From the multicolor prints I ran, I didn't see any parts that I thought looked lesser quality because they were printed with the secondary extruder. However, I wanted to run an apples to apples test by printing a single model or a series of models on the primary extruder and then printing them the exact same way with the exact same settings using the auxiliary extruder so that I could get a better comparison. So I found a model for a game called Hypercatch that reminded me of a game I used to play when I was little and printed out 2 of the catching pieces of it. Before even starting the print, the first thing I noticed was the difference in print times. Both of the catching pieces required 2 different parts, and on the primary extruder, it was 4.5 hours in total of print time, while the auxiliary extruder was right around 8 hours and 20 minutes. So while not quite double, that is a sizable difference. Now let's talk about quality. For the black portion, which is the part you hold in your hand, I didn't really see any differences. However, when we got to the taller sort of main body red portion, that's where some things began to stand out. The model printed with the auxiliary extruder had some fine hairs or stringing throughout the print. And if you angle the print so light shines down and highlights the layers, I found that the overall stacking just wasn't as clean. I also found some fairly small zits or blemishes that weren't present in the piece from the primary extruder. While I wouldn't describe the print that came off the auxiliary extruder as being bad, it did take an additional 4 hours and the results are clearly inferior. As a dedicated support extruder, I think it's great, and for multicolor models where it's either simpler or I just want to save on purging or the overall print time from having to load and unload from the AMS, I would gladly use it, but there clearly is a hit to quality when using that auxiliary extruder. Considering Bambu Lab at this point has plenty of experience with dual direct drive toolheads, this is clearly not a result of lack of experience, and the only thing I can assume is that this choice was likely made to separate or distinguish their product lines a bit more. One of the larger prints that I ran was a model of the Blue Eyes White Dragon from Yu-Gi-Oh! Since this model required a fair bit of support material, I decided to load a spool of PETG onto that auxiliary extruder and use it as my interface layer, so that way I could slice up the model and have a 0mm gap between the primary model and that support material. This started off printing fine, but at some point one of the PETG supports ended up shifting, so I had to cancel the print. I have a fair bit of experience using PLA and PETG or PETG and PLA for supports, but typically this is for functional parts or just simpler models. And in the case of this sort of larger organic sculpted model, it needed not only support to help it from sagging, but it needed support to hold the print up and prevent it from falling over. And in the case of the PETG, because we print with it on PLA to have it not stick all that well, it just didn't provide enough support to keep the model in place. If I were to print this again, I would paint on a bunch of additional supports that weren't in the model with the default settings, so that way it just had a larger bed or footprint to support it while printing. In addition to printing in PLA, I did print out this large model out of PETG, which turned out great, and then I printed out some large mounting hooks for some things in the garage out of ABS. The X1 Carbon was my primary printer and workhorse for ABS and ASA for years, and it did a fantastic job, but having the addition of the heated chamber is just a really nice bit of extra insurance, and it also helps to make sure that you're getting the best possible inner layer adhesion. Now I want to quickly touch on a couple of add-ons installed onto the X2D. These are not included with the base printer, but they were released around the same time, and I think that there will be enough interest that I should at least cover them. The first is the Filament track switch, which is compatible with the X2D as well as the H2C, and Bambu Lab says that this will be coming to the H2D as well in, I believe, Q3. This device lets you feed filament from your AMS into either of the Hotends. So whether you have one AMS or multiple AMSs, they're no longer tethered to left or right Hotend. They can, each time they swap, switch between the left and the right. This is powerful for a few reasons, with the first being just the overall convenience of it. When I printed out these two benchies, I had both colors loaded into the AMS. Now, with this printer, it would have probably made more sense to load one into the second extruder, but with the Filament track switcher, I was able to tell it to load one color into the left and the other color into the right. Now, this did mean that on every color swap, it still had to load and unload the filament, but it did not have to do any purging, so there was no waste material, and I saved a bunch of time that normally would have gone into purging the old color to push the new color in. To take things a step further, for prints that have more than two colors, it's able to dynamically map them to either Hotend based on what's going to be the most efficient and waste the least amount of material. There's a neat little graphic on the product page that shows what the print swapping process would look like for a 3-colored square if you had 2 filaments loaded into one AMS and 1 filament loaded into another without the track switcher, and then an example of it with the track switcher and how fewer amount of swaps and purges are required to print out that part. This is an add-on that I'm really glad to have, and I think that anyone doing multicolor printing on one of the compatible machines will definitely benefit from using the track switcher. The second add-on is the TPU Feed Assist module, which is compatible with the H2 series, X1 series, P1 series, P2S, and X2D machines. This comes sort of as a kit or a box of parts and requires you to print out a handful of different pieces before mounting the controller, the wires, the extruder, the switches, and the LED inside of it. Once assembled, a bracket gets mounted to the back of the machine, and the TPU assist module just sits on the side of the printer. Whenever I've printed TPU or PEBA on the H2C or H2D, the process has involved me removing the AMS, removing the top glass cover, using this really large, I can't even find it right now, big printed contraption that basically holds the spool of filament directly above the toolhead. And while I, from experience, can vouch for it working and working pretty well, it's just not a enjoyable process, and it makes me want to print with flexible filaments less on this machine because of sort of the setup process involved. With the feed assist module, you get a secondary extruder that helps pull the flexible filament or TPU from the side of the machine into your primary extruder. Having the secondary extruder mounted right around where the filament enters in helps to reduce drag caused by TPU and removes the need of that whole top mounting contraption to print with flexible filament. This is not compatible with the standard AMS or AMS2 Pro, but it can be used with the AMS HT or high temp. And in my case, I just had a poly dryer actively drying filament and fed the TPU directly from that dryer into the TPU assist. There are a couple caveats with this that I want to make sure that I cover. The first being that it is only compatible with filaments up to 85A shore hardness, which I would say 95 to 85A range is probably covering the majority of what people are printing. But if you are printing with something softer than that, it is not recommended to use this out of risk that it will still clog and get tangled in the gears. In that instance, you'll want to still use some sort of a top-mounted direct feed into the toolhead setup. Also, based on my experience and comments on the wiki page, the TPU feed assist module does not work with the filament track switcher, which is fine, but when you try to even load filament into here with this connected, it throws an error. So I had to power off the machine, disconnect the filament track switcher, power it on, and then I was able to use this. It would be nice if Bambu Lab added some sort of setting, maybe I missed it, but I didn't see it, into the screen that lets you disable the filament track switcher, so that way you can use the module and not the track switcher without having to physically disconnect the cable, which is located on the back of the machine. So what are my thoughts on the X2D based on my time with it so far? Well, the X1 Carbon was my primary workhorse for years, and having this as the Gen 2 for the X series, I had my hopes set pretty high, and in a lot of ways, Bambu Lab was able to deliver. You've got twice the cooling, an added chamber heater for high temp filaments, and 2 hotends instead of 1. Swapping out hotends when necessary on the X1 Carbon never took me longer than a few minutes, but I've really grown to like the latch system that was first introduced on the A series, so having this newer printer using those hotends is something that is a nice quality of life improvement. I never had issues with the carbon rods on the X1 Carbon, but I know many people will be happy they went with stainless, and the lots of little things, the full-size USB port, the slightly more responsive screen, the camera that appears to get higher frame rates, all add up to just make it feel like most things were upgraded to some extent. The biggest thing I wish they had done differently on the X2D was the decision to make that secondary hot end or secondary extruder a Bowden setup. On the product page, they advertise the toolhead as being the lightest dual hot end system ever. And while this might be true, they compromised on speed, material compatibility, and overall quality to achieve that. For some, those trade-offs won't matter, especially if you plan on just primarily using that auxiliary extruder as a support extruder. But personally, I would have gladly taken some additional weight on my toolhead if it meant that both the left and the right hot ends and extruders had the exact same functionality and capabilities. My only other gripes are that I wish the front door opened all the way. I've gotten really used to that on the H2D and the H2C, and while this isn't exactly a core machine thing, I just wish the upgrades that came out or were installed integrated a little bit nicer with the machine. Maybe this is due to them needing to make the TPU assist and the track switcher compatible with a wider range of machines, but as I began adding these things and bolting them onto the printer, I couldn't help but feel like I was looking at some sort of wild science experiment. Functionally, they have been great, so I realized that this might be a silly complaint to some, but given how clean and streamlined Bambu Lab's integrations have been in the past, I would love to see a future generation of printer that has a TPU assist built in, as well as a filament track switcher just in the back of the machine. At a price point of $649 for the printer and $899 for the printer AMS combo, this machine is extremely competitive. And I'm shocked to see that the X2D is at a lower price than what the X1 Carbon retailed at. They may have swapped out the aluminum panels for plastic ones and ditched the LiDAR sensor, but those things have been replaced with a host of upgrades, making this printer a worthy successor to what first put Bambu Labs on the map. And that has been the X2D. I hope that you enjoyed this video and that you have a much better idea of what the printer is and sort of what its overall capabilities are to help you better decide whether this is the right machine for you. If you have any additional questions, let me know in the comments and I will do my best to answer. As always, if I don't know the answer to your questions, I have no problem reaching out directly to Bambu Lab to try to get those answers for you. On that note, don't forget to like and subscribe for more great videos. We make a video just about every other week, so there's always fresh content coming your way. If you want to support the channel further, I'll have links in the description over to our Patreon, where there are some really awesome rewards. Huge thank you to all of our existing Patreon supporters. I appreciate each and every one of you for allowing me to come back every single week and spend more time doing what I love, which is making content for you all to enjoy. On that note, this has been Daniel from ModBot. I look forward to seeing you guys in my next video. Peace, guys!